All right, so first thing we're going to do is plot the parabola. So this parabola right here, it's about the most simple parabola equation you can have. Isn't that your general parabola formula? I am going to go ahead and try to put it into standard form just so that you can see some of the things that you need to be able to find when you're finding this point of tangency. I've got a parabola. Would you or would you not agree that this point is on that parabola?
Yeah.
An x value of 1, if I plug it in for x and square it, don't I get a y value of 1? So that is a point that's on my parabola. I'm going to find the equation of the line that's tangent to that point. So step 1, take your equation. Let's look at it in standard form. So the squared term goes on the left, the non-squared on the right. What's the vertex? It's what? It is 0, 0. So if I were to put this with a parentheses, I would have x minus 0 squared equals y minus 0 squared, or not squared. So our vertex is indeed 0, 0. So I'm going to plot that. Then if I were you, I would, because you want some room to see what's going on. When we look at our focus, because we're going to need to find our focus, you're going to see how small our focus is. What's the number that's in front here? 1. It's understood that I have a 1. Isn't that value equal to our 4p? So, step 2, we're going to find the focus. So I'm going to take my 4p and set it equal to 1, divide by 4. So none of this is new. So p is equal to 1/4. That's the distance that the focus is from the vertex. Does this parabola open up, down, right, or left? With the x being squared. X being squared, so hold on to your x-axis, right? Hold on to your x-axis. Can't you only swing up or down? So does it swing up or does it swing down? With p being positive, up. So this is a parabola that opens up. You need to know what direction it opens in order to plot your focus. So because my focus is going to be up here somewhere, would that be 0, 1/4? My focus is going to be 0, 1/4. I want to make sure that I can see what we're going to be doing for the next few steps. So go ahead and break this into quarters. This is 1. This is 1. Negative 1. And negative 1. So my focus is going to be right here. And it is the point. I'm going to put it over here, 0, 1/4, because we need to be able to see on the right-hand side. Then our point that our line is going to be tangent to is here at 1, 1. Your book likes to call this point P. Why might I have an issue with calling that point P? Because we have a P here, right? And lowercase p and uppercase p look an awful lot alike. So I'm going to call this point Q. And that is the ordered pair 1, 1. Wouldn't it have a sister point? This would be our axis of symmetry, right? Wouldn't it have a sister point over here at negative 1, 1? The reason why I'm doing that is so that we can get a good shape to our graph, our parabola. So my parabola, my pen's going to work. A little shaky. There we go. So there's my parabola. And if I were to draw a line that is tangent to that point and the parabola, I mean, I could do a lot of different points, but I want to make sure that it only touches it once. And at this point, we're only guessing. Wherever you draw this line, it may or may not, wherever it hits here, it may or may not actually be that point. So you have to be a little giving in the part of the axis, whether it's the x-axis or the y-axis, this one happens to be the y-axis, that it hits. So I'm going to go ahead and get it so it kisses it just so. So here's my tangent line. Oops. I want the equation of this line right here. This is our whole goal. Equation of that line. What do I need to know to find the equation of a line? The slope and y-intercept. Don't I need to find y equals mx plus b? In order to find the slope, I need to have 2 points. I only have 1 point. Wouldn't it be handy to find this point right here, which is, for our case, it looks like -1. It's really 0, b, because this is not my y-intercept. B is my y-intercept. Technically, I don't know this point right now. But we do know that it's below the focus. And we definitely know that that b is going to be a negative number based on our picture, right? It has to be negative. It's important for you to realize what sign b is, whether it's positive or negative, because it's going to make a difference. I'll show you as we go through the problem in a minute. So I have this point, and I have my focus point. So I have 3 points here. Those 3 points creates a triangle. So I have a distance from here to here, and I have a distance from the focus to this point. This distance here and this distance here. We're going to call this distance from the focus to Q, I'm just going to call that d sub 1. And the distance from the focus to this y-intercept, I'm not going to call that d sub 2. Now there is a statement of fact that you need to know. Essentially, this is a theorem. We have found that any time that we have a point of tangency, the y-intercept and the focus, an interesting thing occurs. So if I were you, I would write this down. This is your statement of fact, or a theorem, if you will. The tangent line, and this is the big connection that you need to make, makes equal angles with the following lines. Following 2 lines. First line is going to be the line from the focus to point Q. Yes. And point Q in our world is the point of tangency. So that's one line. Then the second line would be the line from the focus to the y-intercept. In this case, it's along the y-axis. But the line from the focus to the y-intercept. And again, when I say y-intercept, bless you, it's the y-intercept for the line of tangency. So if this tangent line makes equal angles with these 2 lines, the equal angles would, they're implying that the equal angles are here and here. So as you look at this triangle, what else can you conclude from the fact that these 2 angles are equal? Well, the angles do add up to 180, right? But that doesn't matter. I don't want to know angle measures. These 2 angles being congruent leads you to a conclusion regarding the side lengths of that triangle. What sides are congruent, Jason? Oh, that was Jason. The sides, say it, opposite those angles. Remember, all the way back to geometry. If 2 angles are congruent in a triangle, then the sides opposite those angles are also congruent. It's a theorem in geometry. So this side, d sub 1, is congruent to this side here, d sub 2. So essentially what we are concluding from this entire fact is that d sub 1 is congruent to d sub 2. but you have to know what d sub 1 and d sub 2 is. And the focus is the focal point of those, not the origin. Focus to the point of tangency and the focus to the y-intercept. Those are those lengths that we're looking at. So I'm mainly concerned with this length and with this length. So knowing that those lengths are equal, for d sub 1, don't I know both ordered pairs that bound that line segment? Can I find the distance of a line segment in the coordinate grid when I know two ordered pairs? What might we use for that? The distance formula, right? The issue comes into place when I find this distance. I only know one ordered pair. I don't know that one. I know part of it. But I do know that this is equal to that one. If I find that distance, won't this distance equal the same thing? And once I know what this distance equals, I only have one unknown part in my distance formula, which would be y sub whatever I choose to let that be, 1 or 2. Right? Can't I then solve that equation? So there's many processes to this problem. So first step, I'm going to go ahead and find, so step 3, find the length of d sub 1. So we're going to use our distance formula. So d sub 1 is equal to, make your template. I'm going to take the difference between the x values and square them. Add that to the difference between the y values and square them. Here's my x's. So I have a 0 and a 1. So I'm going to choose to do 1 minus the 0. Those are my x's. Since I started with this one, I'm going to start for the y's with this 1 minus the other y of 1/4. Go ahead and work the problem. So now I have the square root of 1 minus 0 is 1 squared plus, what's 1 minus 1/4? 3/4, and then that's squared. So 1 squared is 1, plus 3/4 squared isn't that 9/16? What am I going to convert 1 into so I can add 9/16 to it? 16 over 16. So then add those together. 16 and 9 is 25 over 16. Can't you take the square root of 25 and the square root of 16? So d sub 1 is equal to 5 over 4. No, it is not plus or minus because we are not, can distance be negative? So that's why. And we're not using a quadratic formula. And that would be that formula, right? So now I know d sub 1. So d sub 1 has a distance of 5 over 4, right? That means this has a distance of 5 over 4. So then step 4 is going to be to find the length of d sub 2. So same way, but here's where the important part lies. You have got to think of the value of b and what sign b is. Is b going to be a positive number or a negative number? B is going to be a negative number. So when we set up our distance formula, d sub 2, this is imperative because depending on the problem will depend upon where you put b in the distance formula. We still have our x's that we're subtracting and squaring, the difference, and we still have the difference of our y's and squaring those. As I look at these two values right here, I'm going to use the 0 1/4 and the 0b. Now the x's are no issue. Aren't the x's 0 and 0? Aren't we just going to do 0 minus 0? For the b's, I could choose to do 1/4 minus b or b minus 1/4. Let's think about this. B is a negative number. I want this value here, this entire value that's inside those parentheses. Once I subtract those two values, that needs to be, you need to make sure this is a positive value. That's not going to mean anything to you unless you listen to what I have to say about it. That's not to mean that we want b to be positive. I want the difference in my y values to be positive. So if 1y is 1/4, and this y here, we don't know what it is, but it's negative, what happens if I take 1/4 minus a negative number? You'll have 1/4 plus a positive number, won't you? Won't the value then be positive in here that we're squaring? Okay, so I want b to be second. If I have b be first, I would have a negative number minus 1/4. That negative number minus 1/4, won't it just make the negative number bigger, a bigger negative? Think of it in terms of what's negative 1 minus 1/4. Wouldn't it be a negative 1 plus a negative 1/4? Your value inside that parentheses would end up being negative. We don't want that. So in our case, we're going to put b second. If you put b first, and I'll show you when we get down to the end here why it won't work out, because I know b has to be negative. And it wouldn't matter, even if I had this parabola opening down, if I had the parabola opening down, would my focus be in here? Would my focus be negative, and wouldn't my y-intercepts, because now my line of tangency would go this direction, would my y-intercept now be positive? I would still want the value in here to come out positive. I can manipulate this always to be either positive or negative. You've got to manipulate it so it'll be negative. So you have to really think about what value is b. If you don't sketch this, you're not going to be able to tell. So I've got the 1/4 minus that b. What's 0 minus 0? 0 squared. No, you're not going to do minus a negative b. When we solve for b, it should turn out to be negative because we know it should be negative and it will turn out to be negative if we do it this way. If we do it the other way, it's not going to work out correctly. So this is going to disappear. All I have left is 1/4 minus b squared. What's the square root of that? 1/4 minus b. In order to solve this, I cannot have two unknowns. Isn't d1 the same as my d sub 2? Can't I replace d sub 2 with 5/4? You could have done that at the very beginning. You could have, instead of had this, had a 5/4 here, right? How do you solve for b? Subtract 1/4. Wouldn't that give me 4/4 over here? Equals negative b. How do you solve for positive b? Multiply by negative 1. This is a value of 1, isn't it? So 1 times negative 1, doesn't b turn out to be negative 1? Is that the value that we expected to have for b? Yes. Now, what would happen if I had reversed the b? Right here, wouldn't I have b minus 1/4? True? If I had b minus 1/4, wouldn't we be adding 1/4 to both sides? Wouldn't you get 6/4 on the left with a positive b? That's telling you that b would have been 6/4 or 3/2. Should b be positive? No. So my point is, it's really important that you put that b in the right spot. Otherwise, you're going to get the wrong sign and the wrong value for your y-intercept. You have to be aware of what sign that y-intercept is, because otherwise you're going to have to redo that part. So always be aware of what you're looking for and be looking for that. So now that I have b, I can replace my b with a negative 1. Oh look, just so happens we hit negative 1. It's only because I already knew the answer to begin with. Alright, so now I can start to find the equation of my line. I have 2 points. I already have my y-intercept, isn't it negative 1? So right here my plus b is a minus 1. So your slope formula, last part, so I'm going to put 5 up here, so I'm running out of room. So I'm going to find the slope of the tangent line. Because this gave us, and you might want to write yourself a note here, this is our y-intercept. That's why we called it b. So your slope formula is it y over x or x over y? difference of your y's over difference of your x's, or difference of your x's over difference of your y's? Y's over x's. Slope is rise over run. It is just the reverse of plotting a point. So if you recall, your slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I don't really care whether you start with y sub 2 or y sub 1, to be perfectly honest, but whichever one here you start with, you must have that same x that belongs to that ordered pair starting down here. So if I start with this -1 first, I better have this 0 come first in the denominator. If I start with this y value of 1 first, I better have that x value of 1 be in the denominator. So to me it doesn't matter. You choose. I'm going to label these though as x sub 1, y sub 1, x sub 2, y sub 2. So if this is my y sub 2, I'm putting -1 in here, and then I'm subtracting 1. My x sub 2 is 0, and then I'm going to subtract the other x sub 1, which is 1. So for my slope, add the opposite in both places. I get a -2 over a -1. What is my slope? +2. So then finally I can write my equation. And that's what we're looking for. So I've got y equals, my slope is 2x, my y-intercept is -1. So the equation of that line is 2x minus 1. Of course, you can always check this on your calculator by putting in, for y equals x squared, and then the next y equals, put in 2x minus 1, and then check the intersection of these two graphs and make sure that the intersection comes out to be 1, 1. Checked. Now so that's the difficult question. There's a lot to that process. You need to learn the process. So this you already know how to do. These you already know how to do. All the pieces you know how to do, and the math itself is easy. It's that process. So what you have to really get through your head is the fact that d sub 1 is congruent to d sub 2. And what is d sub 1 and what is d sub 2? Starts at the focus. Goes from the focus to the y-intercept of the tangent line, the focus to the point of tangency. So if I have time when I'm done here, I will do a problem out of the book where the parabola opens down, or right or left. So I'll find one that does that. Look at the last problem. So instead they could give you the equation of the parabola and the equation to the tangent line, and they want you to find the point of tangency. Isn't the point of tangency where the two intersect? Right? So for this parabola and this tangent line, they should have one point that's in common. Isn't this the equation of the tangent line that we just found? If I solve this for y, wouldn't I add a 2x to both sides, and wouldn't I subtract a 1 from both sides? Isn't that the exact same tangent line that we found, and isn't that the same exact parabola that we were given? Don't we already know the answer to this? The intersection should be what? 1, 1. But we're going to figure it out algebraically. So note to self, this is actually much easier. Since the lines intersect, Caleb. Since the lines intersect, solve each equation. And then in this case, we're going to solve for y. I want you to look at the parabola equation, and whichever one is not squared. So solve for the unsquared variable. In this case, it's going to be y when looking at the parabola equation. If you try to solve for x, it makes your work a whole lot more difficult. Is that better? Well, now I can't unfuzz it, but there we go. So that's why I'm choosing to solve for y. If I had y squared equals x, I would be solving both of these for x. So bear that in mind, that's what I mean by that. Then set them equal to each other. And solve. So that's what we're going to do. We've already essentially solved this one for y. So if they have a point in common, this value and this value must also be equal, if their y's are equal. So we're going to have x squared equals 2x minus 1. How do you solve something like that? Say that again. You're going to have to factor, because you've got a squared term and an x term. So we're going to move everything to where the x squared term is positive, and then write in descending order. So subtract 2x and add a 1, set it equal to 0. If you don't recognize that that's a perfect squared trinomial, you're going to take your bookends, which is 1 times 1. That gives you a positive product. That means you're adding the factors of 1, and you're looking for the middle term, which is negative 2. What factors of 1 add to give you 2? 1 and 1, there's only one set of factors for 1. Fortunately, they do add to give you 2. R2 is negative, so both of these would have to be a negative to add to negative 2. So it factors as x minus 1, x minus 1 equals 0. Since they're both the same, which we should expect for this type of problem, that there would only be one answer because they only intersect in one place if it is the point of tangency. So x minus 1, set that equal to 0. X has to have a value of 1. So this is our step 1. Step 2 would be to find your y. Plug it into either equation, it doesn't matter. I would prefer to plug it into the shorter one. So if I plug in my x value that we just found, wouldn't y end up being 1? So your final step, write it as an ordered pair. Therefore, your point of tangency is 1, 1, and in this case, that's what we expected. So essentially for this problem, you're going to take both of your equations, solve them for one variable, make it the easier of the two variables, the non-squared one. Solve, you'll most likely have to factor, and then once you find one value, plug it in to find the other value. Any other questions? Yes. Because these are the two, I essentially have a system of equations, right? And I'm essentially using substitution. If they have a point in common and their y's are exactly the same value, I don't know what they are, but I know that they're equal, then that means the right sides here would also have to be equal. So that's why I set them equal to each other. I replaced, I took this x squared, I really took that y there and replaced it with that 2x minus 1. So you'll always set them equal to each other in this case. I wouldn't use the first one. I mean, only because I look at the parabola to decide which variable I'm going to solve for. I mean, you could have written it as 2x minus 1 equals x squared. That's okay. Then I would have moved everything over to the right. You'll still have this, essentially. True? Anything else?